Hello everyone. In this lecture, we are going to discuss about variations of Turing machines. There are several variations of Turing machines. We are going to discuss about only three. Okay, multiple track Turing machine, non-deterministic Turing machine, and multiple tape Turing machine. So we will discuss about it one by one. So first one is multiple track Turing machine. So here the tape is divided into multiple tracks. Okay, k number of tracks. So for in this example, we have considered three tracks. Okay, tape is divided into three tracks, and this one is finite control. Okay. So consider one example problem. Construct a Turing machine to take input greater than 2 and check whether it is even or not. Okay, so for checking the given input is even, first we need to place the input on the first track in between hash and dollar. Okay, so in this example we have placed number 13. Okay, number 13, binary equivalent for 13 is 1101. So we have placed 1101 on the first track in between hash and dollar. The remaining symbols are blank by default. Okay, then integer 2 must be placed on the second track. Okay, integer 2, the binary equivalent is 10. 10 is placed on the second track surrounded by blanks. Then copy the input on the first track onto the third track. Okay, so initially we have placed 13 and that 13 must be placed on the third track. Actually, this in this problem we have placed 11. This is after subtracting 1. Okay, this is one example. Initially we have placed only 1101 on the third track. Okay, then subtract the second track number from the third track. Okay, second track contains 2 and we have placed 13 on the third track. Okay, so we have to subtract. So we can see this by example. uh, Subtract second track number on the second track means 2 from the third track. So third track contains 13, second track 2. Okay, subtract this. So if you subtract, you will be getting 11. Okay, so suppose if the remainder is equivalent to the number on the second track, then the number on the first track is even. Okay, so if we are getting 2, okay, if the remainder is equivalent to number on the second track is 2. So if the remainder is equivalent to 2, we can say that the number on the first track is even number. Okay, but here we are getting greater than 2. So if the remainder is greater than 2, continue this process, continue the subtraction. Okay, subtraction process until the remainder on the third track is less than or equal to 2. Okay, so here we are getting greater than 2. Okay, so now we have to again subtract this number on the third track with 2. So now we are getting 9. So 9 is also not equivalent to the number on the second track or less than. Okay, we have to continue this process until the remainder is less than or equal to 2. So here the remainder is greater than 2. Greater than 2 means we need to continue the subtraction. Okay, number on the third track must be subtracted from the number on the second track. Okay, so here after subtracting 2 one time from the 13, we are getting 11, right? So that is placed in this diagram. Okay. Then here also number is greater than 2. So subtract this, we are getting 7. 7 is also greater than 2. So again subtract this number by 2. So 5, again it is greater than 5 is greater than 2. So again subtract 2 from this number, 3. So 3 is greater than 2. So again subtract. So now we are getting 1. 1 is actually less than 2. Okay, so less than 2. So finally we may be getting 2 answer. 2 or less than 2. Okay, so if it is equivalent to 2 means we can say that the number on the first track is even. But otherwise here we are getting less than 2, right? Less than 2 means we have to say that number on the first track is odd. Okay, so since we are getting remainder less than 1, we can say that the number on the first track is odd. Okay, so this is multiple track Turing machine. We can discuss about other variations in the next videos. Thank you.